All right, now we look at crazy trig limits. These, though, are going to make use of the sine theta over theta. The limit as theta goes to 0 is going to equal 1. We are going to exploit that thoroughly, and we're going to do it using a trick that is like creative substitution and pattern matching. This first one, though, is the second most used trig limit. And we're going to use the first one to prove the second one. So 1 minus cosine theta over theta. Man, when I was in school, this was the test question. Like, they went over it in class, but like, this is the one you had to prove on test. And we're not doing that as far as I know. I'm just like saying if you took a calc course before, you may have already had to do this. All right, so we first check, we plug in the theta. So 1 minus the cosine of 0. Cosine is the graph that starts at 1, goes down and back up. So the cosine of 0 is 1. So 1 minus 1 is 0 over 0. Our usual suspect. All right, so we need to do something else. Now this one, especially since it's trig, it may have been a while, but we are actually going to use one of the previous techniques, the one we did with radicals. We are going to multiply by the conjugate. But there's no square root, but we do have two terms being subtracted. So if I copy those same terms but change it to addition, I will still get that difference of squares interaction. But if I do it to the top of a fraction, I can only multiply by a crazy form of 1. So I have to put that craziness on the bottom. The good news is, though, like the limit as theta approaches 0 of that is actually 2 over 2. So if we can get one of these zeros to cancel out, like, we'll be golden. All right, so on top, 1 minus cosine theta times 1 plus cosine theta. We'll get the 1 times 1, and then the negative cosine times positive cosine because the inside-outsides cancel out. So minus cosine squared theta. And on the bottom, don't multiply it out, just leave it factored. So now you got to reach your brain cosine squared. There's a thing about cosine squared. An important thing. A thing we use. Yes, there is. And I will tell you the thing. The thing is called the Pythagorean identity. And that is that sine squared of an angle plus the cosine squared of that same angle will always equal 1. So if I take my Pythagorean identity and minus the cosine squared over, it's sine squared. So we can literally say, oh, no, this is just sine squared now. All right. So now, if I plug in that 0, still going to get 0 over 0. The sine of 0 is 0. But I can make use of my trig limit now. Because the problem here, it's not that this going to just 0 is a problem, it's that 0 over 0 is unknown what it'll do. So I'm going to split the sine squared into sine times sine, and I'm going to group into two different terms. So we're going to have sine theta over theta times sine theta over 1 plus cosine theta. Now I'm going to go ahead and write that limit back in. And we also know the limit distributes across multiplication, so this thing here actually can go in there. And now this first guy is literally our, remember, sine theta over theta as theta goes to 0 is 1. And then this other one, we can plug it in. Sine of 0 is still 0. But now on the bottom, 1 plus cosine of 0. Cosine of 0 is 1. So this becomes 1 times 0 over 2, which is a definitive 0. So that's a whole lot of crazy work. Some of that is because I like to write a lot of steps to be clear about what I'm saying. But we proved that that little limit we started with is 0. That looks weird, so now I erased part of my work. All right. There are 3 more questions, so I'm going to shoehorn another question onto this one. Now this one's a little uglier. So we're still going to go looking for our sine theta over theta. But first, we have to rewrite the tangent into a form that's more familiar. So the tangent is sine over cosine. So because the sine of 0 is 0, the tangent of 0 is 0. So this is still giving us our 0 over 0 sus form. So first, I'm just going to make the change. Tangent of 4x is the same as the sine of 4x over the cosine of 4x. And then this is still being divided by the sine of 3x. So our sine of 4x and our sine of 3x, like those are the things that go to 0. This over cosine 4x, we plug in 0, we're going to get 1. Like that guy's fine for the limit. So we just got to figure out how can I make these signs work better. So remember, we're looking at sine of thing over same thing. Like that's one of the ways to interpret our sine theta over theta is those thetas are placeholders. I can put anything I want there as long as the limit of that thing goes to 0, then sine of that thing over that thing goes to 1. So when I have the sine of 4x, what I'm wanting to see is the sine of 4x over 4x. The bottom where I have sine of 3x, I want to see sine of 3x over 3x. So both of those are needing x's, and then we're also going to have to make sure they have the correct numbers. So first, let's get the x's in there. So this is going to look a little weird because we're actually going to make things more complicated. But I need to see sine of 4x. I need an x on the bottom there. And I need an x on the bottom down here. It looks very silly, but we are shoehorning those x's in because we're aiming for that sine ugly over ugly. All right. So I'm going to rearrange this a little. We've got our sine of 4x. I'm going to put the over x with it. And then over here, that cosine was on the bottom. And I do want to preserve where it was just in case. And then in the bottom of the overall fraction, we now have the sine of 3x over x. All right. But remember I said the uglies had to match. So here, our sine of 4x, it's just an x on the bottom. I want that to be, in fact, I need that to be a 4. So if I want to put a 4 there, that is multiplying by the 4 on the bottom of the fraction, I need to make sure that I'm multiplying by 4 on the top of the fraction somewhere. So I want this 4x to stay with the sign, but the other 4 that I have to multiply by to balance it out, That's not going to be included in that particular limit, so I'll throw it over here with the other guy. Now we're going to do the same thing down here. I want to multiply by a 3x on the bottom. Like I already had the x, so I'm multiplying by a 3. So I'm also going to multiply by a 3 on top of the small fraction on the bottom. I know. So we've taken care of our numbers. I've got sine of ugly over same ugly. And then I have sine of other ugly over same other ugly. So these guys, the limit as x goes to 0, 4x also goes to 0, 3x also goes to 0. So those guys are all going to evaluate to 1. So really, the only part that I actually have to care about now is this other part. What does 1 times 4 over cosine 4x over 3 go to? Well, let's go ahead and sneak in our limits. And this is one of the reasons why I like the colors and I like the video. Later on, that's in a different color, so it was a different step. And you can see before I didn't have it, now I'm putting it in. I mean, technically there is a bad handwriting. Here with the 3, but the limit is x approaches 0 of 3 is 3. So this guy goes to 1. This guy also goes to 1. So now we just need to look at these. 1 times 4 on the top is going to be 4 over the cosine of 0 is 1. So let me make that fraction bar a little less huge. But I am going to put some grouping around the top and the bottom, because otherwise this looks horrible on a piece of paper if you go walk away for 2 minutes and come back. If you don't have those parentheses to be like, this was the thing on top, this was the thing on the bottom, like here's the big fraction versus the small fraction. This is why mathematicians, like, as much as we play around with complex fractions and say they're cute, we don't really like them. And it's this ambiguity. If I just write 4 over 1 over 3, did I mean 4 divided by 1/3? Or did I mean 4 over 1 divided by 3? Because they're not the same. So let's be very clear. Bad math. Now, if you're in the middle of working a problem, you write this, and then on the next step, you're like, and this equals 4/3, because that's how your brain was thinking through and doing the work. That's okay. Like, I'm not going to totally freak out on the test if you do this. I will probably make a note of it, like write in the parentheses for you. But I'm saying for like writing your own notes, don't skip the parentheses here, otherwise it looks confusing. But this does simplify to 4/3. So that is what this ridiculous limit finally evaluated to. So I apologize for this video being a little longer, but you know, double speed does make it half as long.